Now we are looking at a sequence that involves perimeter of triangles. So in this question, we have 3 different triangles. And so far, what we know about the perimeters of this triangle is that first triangle have a perimeter of 8, second has a perimeter of 24. Now let's see what we need to do in next part. The perimeter of 3 triangles, A, B, and C, form linear sequence. What does that mean that we are talking about linear sequence? That means that first number is 8, the next one is 24, and then we have another number, so for my triangle C. Linear sequence means that every time I add up the same value in that sequence. So I add up a specific number every time, and every time it is the very same number I'm adding. So triangle C has the largest perimeter because it's the biggest. The perimeter of triangle C is K. So that's what we know, it's K. Where K belongs to N, meaning it is a whole number. Find the value of K. Now, by the way, if you're in the exam and you forgot about what sets are, you open your table to page 23, and here you have example of what sets are. So you can always have a look, and once you see the numbers, you will remember about the sets. Okay, so what value do I add to 8 in order to get 24? Or let's ask differently, 24 minus 8, what do I get? 16, isn't it? So I added 16. That means that to 24, in order to get the next value, I'm going to add 16 as well. So the value of K, if we put in calculator 24 plus 16, we get what? 40. So this is now the perimeter of the last triangle. Now, the next part is saying hence. Hence mean what? With the knowledge we just acquired. What is that knowledge we just acquired? That we know that first triangle is 8, next 24, and now we know that the last one is 40, and every time here we are adding 16. So that's what we know. We know that this is the perimeter of the last triangle C. So what do we need to do? We have to work out the value of y. So how is the knowledge of that, knowing that the perimeter of C is 40, going to help us to find y? So how do we calculate perimeter of a shape? We add up all the lengths. So this length and this length and this length. In this case, when I add up all the length, I'm going to get 40. Okay, so let's write it down. So that will be 5 and y to the power of 2 and y to the power of 2 plus 3. So let's write that down. 5 and y to the power of 2 and y to the power of 2 plus 3. So all of that added gives me what? 40. Okay, so now I can solve that. So what do I do next here? Where am I going with my calculation? I want to find the value of y, so I need to end up with y equal a number. Now, what I have at the moment is that I have y here and I have y here. So 2 of these y can become 1 y, isn't it? I can say I have 1 and 1, so together I have 2 of y to the power of 2. Now, numbers on the other side, so I'm saying 3 join 40, 5 join 40. When the numbers cross from one side of the equation to the other side of the equation, what happened? They change the sign to the opposite. So we have 40 minus 5 minus 3. Now, we want y, not y multiplied by 2. How do we eliminate multiplication? By dividing and dividing both sides of the equation. Because y divided by y is 1 and 1 multiplied by y to the power of 2 is y to the power of 2. Now, obviously, yes, you can do the calculation on the other side. I'm just showing you how the numbers move around the equation. Now, I'm almost where I want to be. I have y, the only thing I need to get rid of that power of 2. How do we get rid of the power of 2? We take a square root of the other side. Now, that concept is very important because we're going to be applying that not only in junior cert, but as well in leaving cert a lot. The principle is always the same. Doesn't matter what power, that is the number of the root on the other side. Just to show you, let's say if that was power of 3, what we're going to have is what we know as a cubic root or third root. That's what it is. Let's say that that power is 28, okay? The principle will be the same. I will have 28 root of the other side. So I just wanted to show you here that it doesn't matter. That's how we connect. That power tells me what number of the root I'm going to have when I need to get rid of the power. Very important concept.